Hello, everyone, and welcome back to our webinar series, Social Media as a Research Tool. We're very pleased today to have Anatoly Krutz from Toronto here. He is one of the co-directors from the Social Media Lab based in Toronto. And if you haven't come across them, do check out their website. Anatoly will give us an overview a bit of the social media lab today, and then we'll more specifically talk about a new tool that they developed called Communal Analytic, where he will also give us a demonstration of how to use it. We're really happy to have you here today. Just a few ground rules. You saw that we're recording this, so the recording will be made available online. So if you can't follow as quickly as Anatoly is giving his presentation, no worries. You can go back to the recording later on our YouTube channel. We will also make the slides available. And as always, we have a chance to ask questions. I would suggest that we just, mostly kind of go through the presentation. However, if there are any clarifying questions, we might briefly interrupt you. If you have questions, please use the Q&A function. This is the easiest way to track questions, and then we will mostly pick that up at the end. So with no further ado, over to you, Anatoly.
Yes, good afternoon and good morning for those of you who are in, East Coast, where I'm currently located in Toronto. Happy to talk about this tool we've been developing for the last several years. It's called Communalytic. It's kind of a combination of two words, community and analytics. And it's really designed by researchers, us at the Social Media Lab, for researchers like yourselves to study online communities and digital discourse, specifically focusing on the discourse that is publicly available. So I will start by just briefly telling you a little bit about the Social Media Lab, just so you know where I'm coming from. Then we'll dive into the Communalytic platform, just highlight some of the features. But because of the time limitations, I decided maybe if greater interest to focus on one of the features, topic analysis that can be performed within Communalytic. And then we will have time for kind of hands-on exercise. So if you wish to follow me on your screens, the slides are shared. There will be a sample data set that you can download and analyze with Communalytic. So we will do that exercise together. But either way, you can just follow us on your screens as well. So you don't have to do it yourself. So about the Social Media Lab. We are interdisciplinary center. We are located in Toronto, as I mentioned. We are part of Ted Rogers School of Management, which is located at Toronto Metropolitan University. Our projects ranges from studying how academics use social media, looking at health implications of social media use, privacy concerns. Lately, we've been focusing on mis and disinformation, how it spreads, how bad actors weaponize social media in different contexts, as well as during elections. Some of you might have known us from organizing the International Conference on Social Media and Society. So if you attended one of our events in the past, hi, and we hope to see you in next year. This is the year off for SM Society, but next year it will be back. In terms of our recent work, so I mentioned we've been looking at mis and disinformation trends online, and I just want to highlight some of the papers recently came out, specifically focusing on disinformation related to Russia-Ukraine war. In this paper with colleague Philip Soares and Philip Mai, we've been looking at, it's based on survey, unlike what we've been examining today, observed data. This is self-reported data from Canadians, 1,500 Canadians, trying to understand whether exposure to disinformation on this particular topic relates to the people's belief, as well as how it correlates with their political views. And interestingly, in Canada, so it's not surprising that exposure was positively correlated with belief. So it could be, people believe in it, they're more likely to seek it out, or could be vice versa. But we also found an interesting trend that far-right Canadians who are right-leaning and far-right Canadians are more likely to believe in pro-Kremlin claims related to Russia-Ukraine war, as opposed to mixed and left-leaning individuals. So that was an interesting trend. It could be, again, the type of sources, the news sources the individuals exposed to, but maybe go beyond of that as well. We did see how some of the media organizations were caught paying far-right influencers in Canada and the US for spreading this type of pro-Kremlin propaganda. So that could be part of it as well. Then what would, since we discovered that, yes, people are exposed to this type of false and misleading claims about Russia-Ukraine war, and the exposure correlates with beliefs, what can we do about it? So we've been conducting an interventional study. That's another type of studies we do, where we've been testing the kind of fact-checking labels on social media posts. Many platforms been testing them out, but to what extent are they actually effective in reducing the engagement with false and misleading claims? So here we've been using open source tool described in the paper, but essentially it allows you to simulate the kind of Facebook-like interface where we ask people to scroll pre-programmed timeline, and they can engage with that, and we kind of randomly insert false claims about Russia, Ukraine, and of course for your studies you can use different topic as well. But what we discovered that just putting a simple label saying that a particular claim was fact-checked by professional fact-checkers and found to be false or misleading significantly reduced engagement and sharing of that false claim. And there was no statistically significant difference between putting just a label at the bottom, at the footnote, saying that it was fact-checked and it's false, versus putting a more restrictive blur filter, like a filter that kind of covers the picture or image or video that is false. Unfortunately, while we see these type of interventions are helpful in reducing engagement and spread with false claims, unfortunately, we know platforms are stopping partnering with fact-checking organizations and experimenting with things like community notes. And sadly, we see that with community notes type of user-driven fact-checking, they're not as effective. And besides for X, for example, we have data with the 1.4 million community nodes that is available. Only around 89, 90%, only 10 to 9% of all the claims are actually visible, the whole platform. So nearly 90% are not visible. So just not shows you not that technique is not as effective. Now, moving on to more kind of discourse content analysis of observed social media data within this staying within this topic of Russian dis and misinformation around the Russia-Ukraine war. We look at also the narratives about Ukrainian refugees, who is shaping them, how they've been weaponized. So here, this was kind of last paper when we still had access to Twitter Research API. It came out last year in first Monday, looking at messages mentioning immigrants, refugees, displaced individuals from Ukraine in Europe and other countries. And what we discovered that the narratives around the immigration, and specifically Ukrainian refugees, were weaponized by pro-Kremlin actors, essentially with the overall goals to diminish support for Ukrainian refugees, but more importantly, undermine international support for Ukraine, the country itself. And we see that on and on, that the topic of immigration and refugee being weaponized in different contexts. And this was just one of the case studies that kind of demonstrated that. In addition to publishing, academic papers, we are a research lab. We also publish public reports. In Canada, we found ourselves kind of lacking data about how Canadians use various social media platforms. In the US, many of us perhaps cited and saw the Pew Internet Research Center data about the internet use in the US. But quite often here, being in Canada, close to the US, many of our scholars would be citing Pew, but at the same acknowledging that, well, we're not the US, Canadian public different. So as a lab, we decided to track that sentiments and usage of social media platforms in Canada through our public reports. So that's out there. And so now going to the tools part. So as part of kind of mandate at the social media lab, we're also developing tools and dashboards for practitioners, for social media researchers. And today we will focus on Communiolytic tool, which is kind of we describe it as a no-code research tool. So you don't need to program to study social media, to collect and study social media discourse. We also have new tools that we don't have time to cover today, but perhaps if we invite it back, one of my colleagues will talk about that in your future webinar series. So the deepfakes tracker, kind of dashboard and project designed to collect all the resources around generative AI use in the social media. The conflict misinfo.org, that's a project that feature many of the Russia-Ukraine misinfo studies that I mentioned earlier, and the Palo dashboard. I understand this group is interested in political science, so perhaps some of you might want to take a look at this platform, Polo dashboard, which we use the Facebook API, Ads Library API, to kind of consolidate and track all political and issue ads around the world, and kind of develop analytics on top of that open access data to spotlight certain actors, maybe taking advantage of some of these targeted ads platforms, see how they spend money, who they target, and so on. All right, okay, so again, today we're looking at collecting and analyzing observe publicly available social media data. I find it useful to start the conversation with this chart that kind of generally shows the type of social media research that is out there. And broadly, we can divide it in non-intrusive and those that requires you to interact with users. So if you're interacting with users, doing things like online surveys or even inviting them for interviews or focus groups or experiments like the one I mentioned earlier when we tested intervention with the fact-checking labels. So those are all interacting with users, and that kind of requires in Canada, and I'm sure in many countries where you're from, or where you at, requires research ethic board approval and review, which means you have to prepare informed consent form, describe what data is collected, how it's being used, and so on. Today we focus on non-intrusive studies where we, instead of going into the specific, maybe surveying specific group of users, you're observing what it's in publicly available data there. In Canada, so that considers to be when you study in publicly available social media posts with no expectation of privacy, and that's something we also have to define, but you would be considered to study documents, not people. And of course, there's always the gray line, and we always say that the ethics, the research ethics is something that researchers have to define and develop. And so you have to certainly consider who you study and where you study in them. If there's expectation of privacy, what is the sensitivity of the topic you study in? So what are the layers of protection you want to put when you publish in your results? How you're going to aggregate it, whether you're going to paraphrase quotes and so on and so forth. So I think we can have a separate webinar just talking about the ethics of responsible social media research, but I thought it's important to acknowledge it first before we get into the actual data. There are 5 principal ways to collect social media data from number 1 listed on this slide that you see here. Let me see if I can get a laser pointer. Data grants. So many of you perhaps applied and got maybe access to things like CrowdTangle in the past, and it was decommissioned and then replaced by Meta Content Library. What I'm hearing that some researchers may wait like a couple months to get access to it. When I applied in November, it took them 3-4 months to give us access to that platform. There are other data grants, but they often like topic focus and limited to certain group of researchers only. Then you have number 2, data providers or data resellers. Those are larger commercial entities that kind of license social media data, partner with larger platforms, and then resell it with some kind of web interface. Quite expensive for research communities. Many of us, don't have budgets to access it, and so this example could be Brandwatch or Talkwalker applications. In addition to being very costly from research perspective, sometimes it's unclear how the data is actually being collected, what sample we're looking at. And so that brings us to the third option, public archives. things like Wayback Machine. Many of you've used it to look at the historical kind of view of web pages around the world on the web. But Wayback Machine also archives social media data. Particularly, they've been doing a lot of samples for Twitter. I'm not sure if they're still doing it, but some of those samples are still available. The issue, of course, it's maybe good for practice, like for a class exercise, but for the incorporated in the research, it's problematic sometimes because you don't know what you study and how it was collected. There are some focus keyword search, but sometimes the website, their scripts, Wayback Machine script just visited at a certain interval, and you might not know what was visited and how the data was collected. So far we've covered 1, 2, 3. Number 4, web scraping. So while it's not legal, of course, because otherwise search engines like Google wouldn't be able to operate if it was legal, it often violates terms of service by platforms. So even though there are a bunch of web scrapers for different social media platforms, quite often they don't work because the platforms simply shut them down. And also, interestingly, if you use one of these tools, you don't know if the data actually you get in um, personalized to that web scraper, because web scraper is a simple web browser that acts like as if it's a user, and the platform may recognize that as a user, start giving personalized results, like based on geographical or IP addresses where that scraper coming from. And so essentially, you as a researcher collected some data, but you might not realize that it's actually personalized results, posts or timelines for a particular location or particular topic. So again, you have to be cautious when using web scrapers. And sometimes some platforms may recognize it as a web scraper and give you some dummy data, some noisy data on purpose, and that's happened as well. So for those reasons, at the Social Media Lab, we tend to rely on publicly available APIs. So what are the APIs? API stands for Application Programmable Interface. Is a kind of dedicated way for platforms to share data with external parties, like developers, like researchers. Different platforms have different rules around APIs. Sometimes they monetize access to APIs, like X, as we all know, charge money now to access their APIs. And sometimes API is free, but quite often have a limit or restriction on the type of data can be collected. And because they're public API, usually that means you only can access publicly available data, which kind of good in a way from research side. You're not going to accidentally scrape something that you're not supposed to scrape. The disadvantage, of course, again, you're restricted in terms of the volume data or the type of data for the collection. So you kind of have to figure out what research questions you may and may not be able to answer with that data. But that's where the questions of triangulation and mixed method approach comes in, outside the scope of today's webinar. So we are focusing on approach number 5, public APIs to collection of social media data. And good news, Communelytic is designed in the spirit of, or with the mind of researchers who are not programmers, so you don't need to design your own scripts to collect APIs, but you go into web interface and deciding what platforms you can analyze based on type of data is available. So this brings us to the item number 2. So let me introduce you to Communelytic. So it is a web-based platform. So if you want to follow me today, you can go to communelytic.org. And the system is designed to be able to collect data from available APIs, analyze it and visualize it, so you can do analysis within the platform. Or some researchers just use it for data collection and then take it, exported the collected data as a CSV or discovered networks as a GraphML files, and then conduct analysis with the platforms, the software they are familiar with. There are 2 versions to Communelytic, so we are kind of maintaining always free version for EDU version that essentially great for smaller research projects, experimentation, and many classes using Communelytic EDU for that. Supports for each account 3 datasets and 30,000 records across the 3 datasets, and you can always kind of delete datasets to free up more space. For research platform, this is community supported version. Pro version, where we use a dedicated commercial hosting provider that supports a little bit more space and capacity to analyze larger data sets. So there you can have 30 data sets and 3 million records across the data sets. So either way, either using EDU or Pro, the features are quite similar in terms of analysis. Really, the main difference is the size of data sets and the number of data sets you can collect. There are four main kind of functions once you collected the data, and we'll talk about what available data sources. But once you collected the data or you brought your own data from CSV files, you can conduct what we call civility analysis, which includes both detection of toxic and prosocial interactions. So that's a text analysis based on machine learning library from Google Perspective API. Or the library called Detoxify. There are two options to do that. But essentially, the idea is to identify those extremely toxic messages or extremely like pro-social messages that support community building. Depending on research questions, you might want to track either or both. Then we have kind of more traditional sentiment analysis, just because the community wanted it. But frankly, I do find that sentiment analysis techniques are not good at catching sarcasm very well. And there's a lot of disagreement even when you show the same message to humans, whether a message is positive or negative, depending on the context. But it's one of the signals you can use for when analyzing data set. The topic analysis is a recent addition. That feature we just introduced it last fall, and so we will focus on that today specifically. And of course, network analysis. As a network scholar myself, I'm always enjoying visualizing social media data sets as a network, and perhaps that could be a separate webinar altogether. All right, so again, if you follow me, please use a DU version. To sign up, you can just use any Gmail accounts. And so once you're in the system, you're going to see the first thing you're going to see is, how do you get data in? How do you collect data? So right now we're working with the APIs that are for popular social media platforms, but but also the platforms that do offer us API access. So Blue Sky as the emerge as an alternative to Twitter with I think was last time I checked between 20 to 30 million users or something. So and it's growing. It has a robust API that allows us to collect historical posts. So essentially, you can provide keywords similarly like what we did with Twitter. You can use Boolean search. You can use different filters. And you can specify the time period. So that's the historical part of it. The second option here, collecting the threads, is essentially if you have a celebrity or public figure posted something and you're only interested in analyzing the replies to that original message, so that would be the threads option. And user timeline, if you have a specific account you want to study, but you want to study all of their messages, so that's that option will pull. Often, useful if you're looking at some media outlets, partisan actors, political parties, if they have presence on Blue Sky, that could be an option to collect data. Mastodon, another alternative to Twitter, has been around, does have an API. The constraint with this API that you have to know which Mastodon server you want to study. Once you can just collect recent posts just to get an idea what kind of messages are posted within a particular server, or you can search by hashtag. Unfortunately, the keyword-based search API does not support, but hashtag is going to compromise. There's something trending, and you want to study the community on Mastodon. And those are still kind of niche platforms, so you kind of have to understand which Mastodon server you study, because they are different by interests the community discuss on Mastodon. They also different geographically, so you can study a Mastodon server in Japan, so that's the type of public sentiments you capturing. The Reddit, many of us perhaps familiar with Reddit, a little bit more than Blue Sky and Mastodon. And there was a lot of drama with the Reddit API. It's still around, it's still working, last time I checked. But it has limited type of data you can collect. So what we can do in Community, we can collect recent posts from a given subreddit. So you need to know what subreddit you want to analyze. And subreddits is how groups are organized on Reddit. And so you pick first the group based on, again, you can do it by topic, by geography, by interests. And so that once you identify subreddits you want to study, then you identify how many recent submissions, threads you wanted to collect. So unfortunately, Reddit API doesn't support the historical data collection right now. So it only will give you like a most, you can have up to, let's say, 200 most popular threads on a particular topic, because you can limit by keywords, but it's still going to look backwards from today till going backwards. Um, there's also another call where it's a feature post. So essentially, it's like live data collection. Give me all messages from this group. So that one, there's a lack. So essentially, it requires a little bit more resources to keep it running. So that feature only available in Pro. The Telegram, some of us interested in looking at that data source. The API is still working. It's a bit headache to get the keys. So essentially, it is working, but for each of these APIs, kind of it's researchers' responsibility to get the API keys for data collection. The community just provide a platform and guides how to get those keys. With Telegram, you have to use your telephone number to have a Telegram account to get that key. But once you have a key, you enter it into your community account, and then you can collect the data. So pretty much the process is similar to with all of these platforms as well, where you get a key first, add it to your personal account in Cumulative, and then you can collect data. We left the Twitter API on. It is working, but it's really if you are willing or want to pay Musk for access to the API, that's how you can access the data. But it's still working, so we left it running. With YouTube API, which, as you know, owned by Google, there are a lot of endpoints or different data points you can collect. For Cumulative, because we focus on conversational type of data, for now we just implemented one data source, data collection, essentially comments on a given video. So let's say you're analyzing a campaign, a marketing campaign, political campaign, or just an influencer interview, and it triggered a lot of comments. The interview or video triggered a lot of comments, and you can analyze the content of that comment. So a network derived from those replies to that initial video. So that's what the endpoint is for. And finally, you might have your own data. Some people use Community just to analyze open-ended interview questions. So if you have anything more than perhaps 100, around 1,000, that would make sense to apply computational techniques. I always say if you have a small set of interviews, like 100 interviews, probably not the best. Computational approach is probably not the best way to go. But so the CSV option is that option that you can bring really arbitrary data for your own analysis. The minimum you need to have a text field, so then you can do text analysis, civility analysis, sentiment analysis. To do network analysis, you have to have two fields, at least in your CSV file spreadsheet, from message the author who originated the message, and reply to fields. So who is this message targeting to? And if you have any trouble getting your own data into Community, please reach out. Just send me email or the lab's email. It's in the slides, and we'll be happy to help you. Are there any quick questions before we get into the topic analysis? Any quick questions?
No, I think we're good for now.
All right. Okay. Good. So let's continue with this one of the features in Cumulative. Once you collected the data or brought your own data, let's say you decided to identify prevalent topics. What are the topics that are expressed and discussed by social media users? And there are many different flavors of topic analysis. Until recently, more traditional topic modeling like LDA, BERT topic, was around, where it would discover, based on your data set of messages, it would discover very abstract topics. It will say, let's say you have 5 topics. And then you can say each topic is described by this set of keywords. And then you have to kind of figure out what is this topic with this set of keywords, what it actually represents. What large language models allowed us to do, essentially, instead of creating or identifying abstract topics from your data set, we can actually group all of your messages into the clusters, and each cluster in that in this semantic space, would then allow us to discover prevalent topics, prevalent themes in your data sets. So this way, you can actually, when you're trying to label or understand the topics that emerge, you can actually read each message. So each dot in this visualization will be the message from your data set. And so you can kind of mouse over and actually read the message to understand what's that grouping of messages is all about. And why did I say that large language models allow us to do that? Because to visualize your data set as a group of clusters, in this case, we're doing three-dimensional space, you need to convert each message in that space, in that representation. So essentially, you have to convert text into numbers, into the vectors of numbers, and then you have to visualize those numbers in that space. And so large language models allows us to do this multilingual conversion of text to this semantic space. And then what you do, you can project, because it's usually represented as a multi-dimensional space, which is kind of impossible to visualize in 3D world. But what we can do is we can project that multidimensional semantic space to the 2D or 3D space. And so that allows researchers like yourself to do more detailed examination of your data set with the idea of, again, identifying groups of posts that are semantically similar. But maybe I'm getting ahead of myself. Let's just quickly look at some basic principle concepts when doing this type of topic analysis with what we call embeddings. So embeddings essentially is that representation of text as a series of numbers. The easiest way, I think, to explain it is to start with the word level embeddings. So just a single word. And so for each word, and in this example, we have words like cat, kitten, dog, houses, man, woman, king, queen. And so for each word, we need to kind of represent them as a set of numbers, but not random numbers, but numbers that will make sense in a way that they will be able to tell us whether one word is most similar to another word. And when we say more similar, we mean more semantically similar. So we kind of understand that cats and dogs, they're all pets. So in the whole semantical space, cat and dog should be closer to each other than to maybe other animal types, or maybe non-living being. So essentially, you have to identify the dimensions that characterize your semantic space. And in this example, let's say one dimension will be, is it likely as a living being? Is it feline? Is it human? Is the gender relevant to the concept? Is it related to royalty? Is it a verb? Is it plural? So you can have those different dimensions describing your semantic space. And then an algorithm will automatically assign a score. In this case, it's, let's say, from -1 to +1. And so the 0.6, let's say, identify that cat is more likely to be living being. So that makes sense. It's not a human, but it's not a negative association with a human, because perhaps the text that was used to train this model that assigns the numbers maybe observed that cats are actually pets and often mentioned in the sentences with humans, with their owners. So but they are not humans. So that number is not close to 1, but it's not negative. So essentially, after you assign all these numbers, what you ended up is the vector of numbers for each word, and that's what we call embedding. And so in this case, how many dimensions we have? 1, 2, 3, 4, 5, 6, 7 dimensions that represents each word. But again, how do you visualize 7 dimensions? I don't know. But I know how to visualize, let's say, 2 dimensions. And luckily, we have several dimension reduction procedures. So these are, statistical approaches that reduces number of dimensions to the given number you want. Many of you have done maybe factor analysis. That's very similar, like principal component analysis. That's the thing. You reduce number of dimensions to the higher level. So in this case, we reduce 7 to 2 dimensions. And once you have 2 dimensions, it means that each word is represented as X and Y coordinates. We can actually visualize it. And that's the result of this simple example where you have cat and kittens visualizing this two-dimensional map close to each other. indicating the semantic similarity. The dogs are a little bit further apart, but dogs and cats are still closer than cats and houses. You can see that visually. And so the idea of now to apply embeddings to the whole sentences or even paragraphs, it's not advisable to apply embeddings to larger text simply because if you, let's say, have an interview that you're trying to represent as embeddings, an interview may have multiple paragraphs, and interview may have multiple questions you ask somebody. So the topic will shift from A to B to C and so on. So with embeddings, you want to try to capture a single topic. And as a result, if you have very long text, it will be all confused. So for that reason, I advise you suggest applying embeddings to shorter text, which social media posts luckily tend to be short on the platform. So they're perfect use case for that. So you may have short messages in online group like this coming from Reddit. People just say thank you. That's one message. Or wow! Exclamation mark. Thanks for your valuable feedback. Thank you for the advice. I will try that too. And so each of that sentence, it's a social media post, now can be represented as a sequence of numbers. But in reality, usually, like in the previous example, we alluded to the fact that each dimension, each of the 7 dimensions, may relate to specific characteristics like a verb, plural, or living being. Well, in reality, we don't care about that. Those dimensions are arbitrary, abstract. So, and depending on a large language model you use, it may represent each sentence, each social media post as, let's say, 512 dimensions, or may use 1,000 dimensions. The more dimensions you have, the more you capture more semantic differences or similarities, which may be good for semantic search, but because we know in advance we're going to reduce dimensions for visualization purposes, quite often, 512 dimensions is more than enough to capture those general differences, similarities between messages. And so at the end, after you go through all these processes, what you want to end up with is some kind of 2D or 3D visualization. In Community, we use 3D visualization just because we thought it captures a little bit more nuances, differences between topics. And you want to cluster those messages in a way that messages that close to each other, they are semantically similar. So we assign a color to visually indicate that semantic similarity. And so once you detect each cluster, then you can label it to describe, oh, this cluster of messages is about this topic and that topic. And in fact, in our hands-on exercise that will start pretty shortly, you will experience that. So I'm going to quickly skip, actually, I'm going to skip some of the slides just so we have more time for hands-on part. But essentially, the slides you have describe the steps I just mentioned. So you get the messages, then you do basic pre-processing, cumulative exclude messages that has less than 3 words, which are not very useful for semantic space. If you only have 1 or 2 words, like what is it about? We don't know. But at the same time, it truncates any messages that has more than 300 words for the reason I mentioned. Then we represent them as a vector of numbers using large language model. In Community, we've experimented with a lot of open access models out there, and we like this Voyage AI API. This is from Stanford University startup, which recently was bought out by Mongo, the database platform MongoDB, but still available as a standalone API. So you don't need to get your own key to access it. It's already integrated in Community. But the reason we like it because it supports multilingual analysis. So in reality, it doesn't matter what language what datasets, what language it uses. It may actually have a dataset may have messages from different languages. It will all map it to the same semantic space, which is kind of cool. It does support around 27 languages. So it's not all languages, but it outperforms or provide consistent results relatively to the other state-of-the-art like OpenAI models. And so once we have the embeddings generated, we reduce it to 3 dimensions, and then we plot it in the three-dimensional space. To detect clusters, we use a cluster analysis, and there are many cluster analysis out there for this type of data, what's recommended is what we call density-based. So HDB scan is kind of density-based clustering analysis where it looks for dots. Each message is a dot in the semantic space. It looks for dots that are close to each other, but far from other clusters, and it's kind of assigns boundaries. And you can see for some data sets where a data kind of touches on overlapping topics, you may ended up with just one sphere, a lot of overlapping topics. It's not the limitation of the approach. It's maybe just indication of your data set being just covering a lot of different overlapping topics, something to keep in mind. And the last step, once you identify the clusters, you have to annotate it. And this is where we emphasize that human in the loop is important. So you're the human, you're the expert of the area. So you really want to examine each clusters that emerge and identify narrative or labels that describe each cluster. We do kind of have a feature in Cumulative that supports automatic labeling, where we use another large language model that kind of look at a random sample of messages from each cluster, like shown in this visualization from Cumulative, where you selected cluster 1 in this case, at this orange set of dots, and then in this case using a Llama, a large language model, suggest a particular label. In this case, will be social commentary on Brazilian politics and consumerism. But as a human in the loop, you really need to cross-validate that results. For that reason, the Cumulative also offers you the actual messages. You will scroll through some of them or all of them, depending on the size of the cluster and your time constraints and the purpose of your research, to say, hey, well, maybe the label is a good start, but maybe it's too broad. Sometimes large language model give you very broad labels. So you can manually interface allows you to override the suggested label, and then you save a new label and you move on to the next one. All right, so before we get into the hands-on part, any questions so far? I
Um,
usually when
yeah,
yeah,
we have
yeah,
about 15 minutes left. It would definitely be interesting to see the hands-on exercise. So, given that there's no questions yet, I would suggest that we just continue with the exercise, and then hopefully we have still a few minutes at the end in case there's still questions.
yeah, let's do that. Okay, so for the hands-on exercise, so I have a data set. We use it at a recent workshop at Hawaii International Conference on Systems Science in January, so it's quite recent. And the link is here. So if you follow us right now, please go to bit.ly link/Higgs25-dataset. Let me see if I can share the actual link. Okay, maybe if you can reshare the link. So download this dataset, but do not, it's a zip file. So Cumulative can read zip files, zipped CSV files. So I do suggest not to unzip it, because there is a limit. So for the EDU version, you can upload up to 10 megabyte file, and the CSV file is a text file, so it zips very well. And because embeddings, it already contains the embeddings data, the file itself is very large if you unzip it. So, okay, so download it to your computer. I'll do the same. So if you follow me, it will open the Google Drive screen, top right corner. You should be able to click download, and it will show you it's been downloaded. All right. And so the next step, you want to go to Cumulative and log into EDU login. Use any Gmails that you have. I use my university email, as our university is Google Campus. So essentially our emails are Gmails, so you can sign in that way. So what you see is just my account. Again, the first option is where to get data. In our case, it will be from CSV file. So click on CSV. We give it a name of the data set. You can just do that, name test, trivial. and then choose the file. And because I just downloaded the dataset, it's in my downloads folder. Like I said, I'm not going to unzip it. I know there's a CSV file inside, but we don't want to unzip it. All right, so now that it's selected, click Import CSV file, and the system will do the magic. What you'll see essentially, the dataset, it's a dataset from Blue Sky. I'll tell you a little bit more about it in a second. But you can see this B character, indicates that the dataset is from Blue Sky, and it's importing. Because the import process happening on backend, you actually want to click to check the progress. It's a small file, so it doesn't take that long to import, but the page doesn't auto-refresh. You want to click check the status to get the dataset into your account. So if you followed me right now, you will see this dataset with the name you gave, and it should have 1,077 records. I'll give you a second. So while you're doing that, I'll tell you a little bit about this dataset. So essentially, there was a tragic accident with the Azerbaijani airline, Christmas 2024, when essentially the flight was trying to land in Grozny, Chechnya, but it was shut down apparently by the air defense, Russian air defense, at the time accidentally. And there were some survivors, some people unfortunately didn't make it. But there was a lot of controversy around this flight because first Russia refused to accept the responsibilities that their air defense system caused that, and there were lots of speculations around what happened. But it was an international case because you have different country leaders, making big statements, at the point that finally Putin came out and apologized to the Azerbaijani president for that. So let's take a look at this data set. So ideally, we want to conduct topic analysis to discover those different kind of narratives, nuances about this case. So once a dataset in Cumulolic, I often suggest to click on dataset overview, this magnifying glass. This kind of gives you, it doesn't do topic analysis first, but it gives you a good overview of the dataset itself. So you have number of messages over time, just to shows you that the data captured from December 25th, but we actually collected it for 5 days. So it goes so that you can capture historical data a little bit. The keywords, the word cloud confirms the frequently used keywords. What it does essentially sometimes it's helpful to see word cloud representation of your dataset because it validates what keywords are present in your dataset. In this case, I believe I used word Azerbaijan Airlines because it was timely and topical. I got all of the relevant posts, but sometimes you might use other keywords. You want to make sure there's no noisy keywords come up. It also allows you to quick exploration of data set by clicking on the words like Putin. If you might not know why Putin was part of the data set, you click and there will be a pop-up window come up. I'm just not sharing that screen, so you don't see pop-up, but if you do it on your screen, the message will show the pop-up window will show messages mentioning a given keyword like Putin or Zelensky, for example, which you may or may not expect in your data set. What you also see by default to improve the user interface experience, we only do in word cloud calculations, frequently used words for the first 1,000 messages. In our case, the data set it's slightly over 1,000, so you'll see this green blue button saying recreate this chart based on full data set. So if you click on it, it will recalculate word clouds for the full data set. In our case, because we're only missing 77 words, it's probably not going to change much. The visual representation won't change much. Then we have also emoji cloud. Some people found it useful to do this lightweight sentiment analysis, like seeing the nature of expressions and sentiments that come in data set through emojis. And we see a lot of kind of signs like international news, breaking news, prayer, but you also have people laughing out loud, signs, angry. So there's a mix of mixed reactions. The final two chart include top 10 posters. So this kind of gives you an idea of, is the dataset being generated by a single account, like a spammer, or it's like there are several users contributing to it. So out of 1,000, there is one active account. It's a news feed. So there clearly some news aggregator on Blue Sky that keep focusing on that news story, posted 111 messages out of 1,000. The percentages here are only shown relatively to the top 10 posters. So that's why you see it's like 47%. Then the second most frequently posted account, it's another news aggregator, looks like, and top news. But other than that, you have mix of news accounts, but other users as well. The reactions quickly give you an idea of do people actually engage with the content, give you median and mean like count, reposts. This is engagement data. It really depends on what platform you're studying. Blue Sky API provides that engagement stats, so we can summarize them as box plots, and they will be in your raw data if you downloaded it. But other platforms may not have that information or may have other type of engagement stats, like Reddit will only have number of upvotes, but not downvotes, for example. So you're gonna have to learn for each data source what type of data available. So now that we examine the overall view, let's dive overview of data. So let's go to topic analysis part. So click on Start Topic Analysis. If you're in the overview page, you can also go to this page in the left side panel, topic analysis here. The message you'll see that the dataset you imported already has embeddings. So you just click visualize embeddings. It just means that we're skipping the step of calculating embeddings with large language models because they are already pre-calculated. When I exported that data set and shared with you, it already had those vectors of numbers for each message. So it's still doing its own like cluster analysis right now and projection to 3D space to create the visualization. But otherwise, the process is faster because we don't need to analyze each message to convert it into embeddings. If you refresh it a couple of times, how you know the process has ended, you should see these three buttons: visualize, open visualization, change clustering parameters, or download your embeddings and clusters. So let's open the visualizations. So you can quickly see this is our data set that is 1,000 messages being represented in this three-dimensional space. The clusters are identified automatically and the colors are assigned randomly. So the fact that it's orange versus red, it doesn't mean anything. The more important part is just to help you visually identify different clusters. In this data set, clusters are nicely separated, but in other data sets, depending on the topic, there may be like strong overlaps. So the color is quite useful to separate the two. And of course, there are some, unfortunate because colors assigned randomly. So you ended up with cluster 1, in my case, and 11, both orange color, but they are different clusters. You can mouse over each dot and you can actually see the cluster number there. And again, because the colors assigned randomly, your cluster 1 may have a different color. There is also a little bit of with the cluster analysis and particularly projection to the three-dimensional space from multi-dimensional space, there's a bit of a random kind of permutation. So your solution may be slightly different from my solution, which is always fine as long as you can acknowledge it, because the idea is to find prevalent topics, and the fact that solutions may be somewhat different as long as you identify the same prevalent topics. On top, you can see that out of 1,000 records, we have 11 clusters identified. There are 8 outliers posts, meaning that there are posts that didn't meet, were too far from to be part of any clusters. In fact, I can see it, they're kind of light gray. If you mouse over, they are shown as clusters. And you can see in my case, they're quite far apart from the core cluster 1. So it would be too much to include them in this particular solution. How do you know it's a good solution? Well, we do provide one of the clustering quality metrics. It's called Davis-Baldwin index, and it ranges from 0 to 1, and we remind people that the low numbers are better. So in fact, 0.3 is quite a good number. Usually, 0.5, you're quite satisfied with that. There's no from what I found in the literature, there's no like hard rules on the thresholds, but we know that the values are higher, meaning the quality of clusters going down. There are more overlaps. How you can experiment in the right side panel, if you click adjust clustering parameters, you can change how the clusters are created. It's a little bit outside the scope of our webinar today, but essentially you can fine tune the clustering parameters based on your particular data set. In this case, it's visually sees that the algorithm separates clusters quite well visually, so I don't feel a need to change anything. But if you do, you adjust things. Keep an eye on this DBI index. Essentially, if you see that whatever adjustments you made increases this DBI index, it means that perhaps you should go back to your previous step. You reduce the quality of clusters. Now, well, this is a nice picture. We know there are 11 well-defined topics or themes of discussion. Now, what are they? So here we go into the examine and label cluster option, the right side, and we want to do it systematically, then cluster by cluster. In larger data set, it's not uncommon to end up with 100 or more clusters. Don't be scared. You know, it would be worse if you have a larger data set, 30,000 records, let's say, or more, and you're trying to squeeze all these topics in, or give me top 10 topics. Well, you can get those topics, but they will be very broad and useless for your research. So what I suggest usually, if you ended up with hundreds of clusters, you can limit your study by saying, I'm only focusing on top 10, let's say, prevalent clusters, prevalent topics. So look, select cluster 1. What it does essentially, it's automatically zooms in on that cluster just to visually show you where it's located. You can still use your mouse to zoom in, zoom out, but that's what it is. Then it shows you there in the pad 276 messages, if you can see. I can hide this here in this cluster, and you can actually use arrows left and right. You can actually read some of these messages. And if you see the trend, you can just name the cluster, label it. Or you can start using by using one of the summarizers like BART from Google or Mistral large language model that takes a sample of posts and proposes a label. So always check, of course, and sometimes, again, models are being too overly broad. So this is a tool to help you researchers. It should not replace you. So here it says Putin apologizes for the Azerbaijani plane crash. So I know this data set and it is accurately represent this cluster, so I can save this label and happy with it. But normally you would review the messages. What happens is that there will be some outliers because the message is on the periphery. So you can see this is a good example. So while the majority of messages is about Russian President Putin apologizes for the plane crash, some of the messages on the outskirts of the clusters, meaning they are less semantically similar because they're far from the core of the cluster. They maybe use similar terms like condolences and may be related to the condolences coming from a president level leader, but they not necessarily fit in the label. So here you have Chinese President Xi sends condolences over this plane crash. So that's something that you have to kind of acknowledge that with this type of analysis, there will be those borderline messages sometimes that may not fit your label very well. So you have to decide whether you adjust the labeling to represent, leaders talking about saying condolences, or you go with the majority, more prevalent topic. If necessary, you can also adjust the clustering parameters to decide not to include some of those not outliers, but peripheral nodes that are still part of the clusters, but may not be well representing the theme of the cluster. So that's how I usually go. And then I go to cluster 2, we repeat the process. We ask, let's say, BART recommending the label. In this case, it's talk about, just give us a label, Azerbaijani plane crash. External interference. So this is, again, knowing the data set. So your normal process will be, okay, read some of these messages, and some of them are not in English. And again, because we use embeddings multilingual and LLM multilingual, it recommended label in English anyway. But if you as an analyst researcher trying to understand it, I usually use browser built-in translators. In this case, either Google the built-in translator, or if you use an Edge browser, you select a text in non-English, right-click, and then say translate it. And once you're confident with this label, then you can revise it or accept it. And there you have it. Once you finish the process, you can download it, the results. Going back to the previous screen, you click download embeddings and clusters, and that will download your CSV or Excel file that will include a messages, all the metadata, so it include like author, date, message, as well as the labels you just assigned, and you can do further analysis. I'll stop here because I think we're running just a little bit out of time. Apologize. But if you have questions and we have time, happy to address now or via email. Thank you.
This was really great, Anatoly. This was really interesting to get a hands-on, demonstration of how this works. This is a fantastic tool, and also the fact that it's for free, so also students, can play with this, can use it for their work. So this is really fantastic. I don't think we don't have any questions specifically about the content now. I think I could raise his hand. There was somebody having problems with getting access who's based in Indonesia. I don't know whether they have any kind of geographic restrictions. So maybe that's worth kind of following up, and maybe just to remind people what's the best way to reach you. We can put the email address in the chat as well. But yeah, I could. Do you want to?
Yeah, I had a question, but Adam Rusovich also raised hand. Should we let him ask his question?
Sure.
Okay.
Yeah. I mean, we're quite a few people now, so it's fine to, yeah.
Hi, can you hear me?
Yeah.
Okay, great. Thank you so much. That was really interesting, and I can't wait to get my hands on it. I'm wondering, do you think that it's feasible, or have you heard of people trying to incorporate this into thematic analysis or discourse analysis, where they initially create some sort of code book of, let's say, for example, you're looking at a political debate and you want to create a code book of different categories and concepts that are being used in that discourse. Could this topic analysis kind of either probably not replace it, but be plugged in?
Yeah, I guess it wouldn't be well fitted for what you describe, in where you have a code and you're trying to classify messages based on pre-existing codes. So something like zero-shot models, maybe some of you use it, trying to do that. With this analysis, the idea was to do exploratory topic analysis to find prevalent themes. So it's more of a kind of bottom-up approach where you don't know what's going to emerge. And most of the time,
Oh, I meant it the other way around. So like in an exploratory sense of creating the code book in the first place, not applying the code book to unseen data, but the other way around.
Okay, so it could, the challenge is that what it does, this process identifies semantically similar messages, and depending on what type of codes you're looking for, it may or may not be useful. So for example, what we see from social media data sets, it may find a cluster where people say thank you a lot, like if it's a welcoming group, or maybe it will find a cluster where people use toxic words a lot, so semantically similar words. Or it may find, cluster like a president of such country apologizes to somebody else. So it's really based on this semantic similarity, more related to topics rather than necessarily the way people communicate. It could be both, but we didn't intend it. But if you discover it's useful for that purposes, and then we would love to hear your use case.
Okay, thank you.
Yeah, I think we're already a bit over time. It's okay. I think that your talk was really a demonstration of this tool that is very helpful for the research community. So I hope, and I'm sure that people will start using this, and it would certainly be great to have you or one of your colleagues back to also introduce some of your other tools. Yeah, if there's no other questions, sorry, did you?
Should I ask or should I just okay.
Oh yeah, sure, yeah.
So, Anatoly, thank you very much. This was very interesting, and so we learned a lot as well. I had no idea. Well, here is my question. So one day, I have a PhD student who came one day with this kind of a data set, right? I think she used Octoparse, and which is one of which falls into category 4 in your presentation, right? Like a web scraper. So and that kind of a data set, and she doesn't have any prior experience in coding and any kind of these things. So and you make it very easy to come up with that kind of data and to do an analysis. So my question is, what kind of challenges can be here for those who don't know at all? What kind of common mistakes we can commit? What kind of pitfalls there are? What should we be careful about when we are judging the quality that is conducted with this kind of data that is collected without any coding?
Most of the challenge comes from not understanding how API works, like what kind of data you've collected. So it's somewhat different case what you're describing. So usually what I see from my students that it is easy to get some data, but then not realizing they're limited to a certain type of data because of the platform. So whether they deal with Blue Sky or Reddit, they have to kind of study what metadata is available, how it's being collected, and how to properly, create that query, like keywords search or hashtags. If the person coming with their own data, I'm assuming they would need to also understand where the data coming from. And the next layer will be, yes, what is the type of analysis that is appropriate? With sentiment analysis, I find it quite kind of one-dimensional. Okay, you find that 70% messages are positive, but it doesn't add a lot of complexity. So now you kind of have to figure out what additional analysis you can do to slice and dice the data set. And at that stage, it's helpful to determine your research questions first, like we just discussed with Adam, where some of these techniques may not be appropriate to answer some of the questions they wanted to ask. We have, for example, feature network discovery, but if your data set doesn't have communication network, like a property where who replies to whom, you cannot build a network. So I think while the interface makes it easy to click, and you create the visualizations, there still needs some level of data literacy there.
Thank
Okay,
you very much.
we're probably just going to leave it there. I really like your suggestion to have maybe one session focusing on ethics. I think it keeps coming up. I mean, when you presented your research at the beginning, I was also like, how did they get that through ethics review to kind of, in effect, spread, false information on social media. So that's an interesting debate maybe for another time. Maybe we can organize a panel where we're going to have you or somebody from your team also present. But thank you very much for coming today to our webinar. It was great to hear about your work. We have actually one more session in this spring series. A colleague also from Toronto, from the University of Toronto, speaking next week, focusing on democratic discourse and focusing particularly on subreddits in Canadian politics. So yeah, you might know Valerie Kinderjari. I think she's doing a PhD at Toronto. So do come along for that as well. And thanks again, Anatoly. And yeah, see you hopefully another time. Thanks, everyone.
Thank you, everyone. Bye-bye.